So we understand that our given, we can say it was circle P. That is literally the symbol that tells you it's a circle. And it was reason our diagram. Or sometimes your teacher would say it was your given, because it was given to you. So about this circle, what do you think we can conclude about it? Or what do you think we can do to make steps forward to solve that AB and CD are congruent? Well, since we said from all radii of a circle are congruent, we can do that. These right here are all radiuses. So from AP, from PB, from CP, and from PD, we can say that all of the segments that are radii are congruent. We can say all radii of circle can bring you to congruent segments. That is a very long property. There's no really official one-word name for it, like addition, subtraction, transitive, substitution. There's no really official name for it. So if we know that all those are congruent, then what else can we conclude? The next step we can think of is take a look at point P. Point P is in the middle of the circle. And what we can do is, since there are lines that look like that and can make angles, we can say that this right here and that right here are congruent. Those are vertical angles. So what we can say about the vertical angles are that angle APB, so APB is congruent to CPD. And we can say, we can use the vertical angle theorem. We can use the vertical angle theorem, because point P is in the middle, and these two angles are congruent, because they are both vertical angles. So, there is something very fascinating about this picture. We have two segments and one angle. We could also conclude that these two are triangles. And when they're triangles and we have two segments and an angle, from the last video, we can say that triangle APB is gonna be congruent with triangle CPD. The reason why is we have a segment, an angle, and a segment. We have segments, angle, segments, angle. So we can say segment, angle, segment. SAS. So now we prove that these two triangles are congruent. But hang on, we don't want two congruent triangles. We're trying to find out if segment AB and CD are congruent. So that and that right there. But there's one more theorem that we can take a look at. We can finally finish the problem and say that AB is congruent with CD. And the reason is CPCTC. Corresponding parts are congruent to triangles that are congruent. So basically, if we know that congruent triangles mean equal parts, then that means that this right here and that right there have to be congruent because all the other parts are congruent. So the summary is we use the radii theorem and figure out all of these are congruent. Then we found out that angle P has two angles that are vertical angles. Then we found the parts to make up an equal triangle. Since we have two triangles, we can understand that they are congruent. After proving that the two triangles are congruent, we can found that AB and CD are congruent because they are parts that make up the triangle, and congruent triangles must have congruent parts. So there we have it. We have now proven using all radii of a circle are congruent. And that concludes the video. I hope this video has helped you understand circle. Thank you for watching Top Opinion Life's Math Industry. Like and subscribe.